Alright, today we're going to be looking at interior and exterior angles of polygons. So first, what is a polygon? A polygon is a closed figure formed by segments called sides that intersect with other sides at their endpoints called vertices. So segments are always straight, so every single side of a polygon should be straight, and they only intersect at each other's endpoints. So these are a couple examples of things that are polygons. These are a couple things that are not polygons. Notice the curved edge, it's not a segment. And then notice that these sides right here are intersecting at a point that is not their endpoints. So that would not be a polygon either. Now there are two different types of polygons, convex and concave. Most of the polygons we'll deal with will be convex polygons, but concave polygons do exist. And you can test to see if something is a concave polygon by drawing a line segment from a vertex to a vertex, and if any of those line segments go on the outside of the figure, then it's concave. So for example, I could connect this point and this point, and that line segment would go on the outside of the figure, meaning this is concave. I can't do that over here. If I connect any pair of vertices, the line segment is either on the polygon or it's inside the polygon, on the interior of the polygon. Now that's a more formal way to check it out. For me, the easiest way I learned it was that concave polygons, it looks like one side is caved in. It's collapsing in on the figure, so it's caving in, it's concave. That's a much less formal way to remember that. We can also classify polygons based on the number of sides, so this is something you should have learned previously. But depending on the number of sides, we have different names for those types of polygons. Now, numbers are infinite, so we're not coming up with names all the way to infinity. There are some names that are not listed here. There are some names for some larger number polygons. But just for our purposes, we're going to stop at 12. Anything beyond 12, you will just take that number and put gon at the end when you're classifying that particular type of polygon. So if it's 20 sides, you call it a 20 gon. If it's 30 sides, you call it a 30 gon, and so forth. Okay? Alright, so let's look at these figures right here. We're trying to figure out how we can know what the sum of the interior angles would be. Okay? So first off, this has three sides. You should hopefully recognize it as a triangle. So you'll notice this column, which might sound strange to you right now. Number of triangles, well, there's one triangle, right? And we should already know what the angles inside a triangle add up to. In every triangle, the three interior angles add up to 180 degrees. So the sum of the interior angles is 180 degrees. Alright, this next figure has four sides. This figure has five sides. And this figure has six sides. Now, what do I mean when I say number of triangles? So what we're going to do is we're going to pick a vertex, and we're going to connect to any other vertices that we can, and see how many triangles it splits the figure into. So if I just pick this point right here, I can connect these two vertices. I can draw this diagonal, and it splits that into two triangles. Now when you're doing this, you have to just pick a vertex and then connect that one vertex to all the other vertices. Make sure that you're not creating new vertices. So for example, I could split this triangle into a couple triangles by just doing this, but I'd have to create a new vertex, and so we don't do that. If you create any new vertices, that's going to cause a problem. Okay, I have split this into two triangles. If we already know that each triangle has a sum of the interior angles of 180, then that means there's going to be 180 degrees in here and 180 degrees in here. So 180 plus 180 is 360 degrees. So the sum of the interior angles here, 360 degrees. Okay, let's split this figure into triangles. So pick a vertex, doesn't matter which one. I connect it to each of the other vertices. And we see how many triangles it splits it into. And you can see 1, 2, 3 triangles created. And again, there's 180 degrees in each triangle. So we're doing 180 times 3. And 180 times 3 is 540 degrees. And then for the last one, we pick a vertex and we connect to all the other vertices. And this time the figure is split up into 4 triangles. So again, 180 degrees for each triangle, so 180 times 4, and 180 times 4 is 720 degrees. Alright, so here are the sums of the interior angles depending on the number of sides. Let's come up with a formula for that. If I knew how many sides there were, could I know what the sum of the interior angles would be? What I want you to compare is the number of sides and the number of triangles, and see if you notice a pattern. What I would hope you notice is that the number of triangles is always 2 less than the number of sides. So, and then once we figured out the number of triangles, we multiplied that by 180. So, I am going to take 180 and multiply it by 2 less than the number of sides. So I'm going to use a variable n to represent number of sides, and I'm just going to subtract 2 from it. If I take 3 and subtract 2, I'd get 1 triangle, multiply it times 180. If I had 4 sides, I would subtract 2 and get 2, and I would multiply it times 180 to get 360. If I had 5 sides, I would subtract 2 and get 3, and I would multiply 3 times 180 and get 540. If I had 6 sides, I would subtract 2 and get 4, and I would multiply 4 times 180. So here's our formula that we can use now. Anytime we are given a polygon, we can just take the number of sides, subtract 2 from it, and then multiply that times 180, and we'll know what the interior angles add up to. So with that information, let's look at example 1. It says find the sum of the interior angles of a 20gon. So n, the number of sides, is 20. So I'm just going to take this formula we just created, and since I know n is 20, I'm substituting 20 in here for n. So 20 minus 2 is 18, and 180 times 18 is 3,240 degrees. Alright, let's look at what a regular polygon is. A regular polygon is a polygon that is both equilateral and equiangular. So if we say a polygon is regular, it's all the sides are congruent, all the angles are congruent. When you were in elementary school and you first learned your polygons, you more than likely were given pictures of regular polygons where all the sides and angles were congruent. A stop sign is a octagon. It's got 8 sides, and it is a regular octagon. All the sides are congruent, all the angles are congruent. A square is an example of a regular quadrilateral. For 4-sided polygons, a square is the one where all the sides are congruent, all the angles are congruent. Those are regular polygons. Okay, so knowing what a regular polygon is, let's look at example 2. Find the measure of each of the interior angles of a regular decagon. So first off, it's regular. All the sides and angles are congruent. It's a decagon, so it has 10 sides. And we want to know what the measure of each interior angle is. Well, we just figured out how to find out what all the angles should add up to, what the sum of the interior angles is. Now, if I know that the decagon has 10 sides, it also has 10 angles. If we need to refer back up here for proof, 3 sides, 3 angles. 4 sides, 4 angles. 5 sides, 5 angles. However many sides you have the same number of interior angles. So if a decagon has 10 sides, it also has 10 angles. And because it's regular, we know all those angles are congruent. So if I can find out what these angles are adding up to, then I can just divide by 10. If there are 10 congruent angles adding up to something, I can just divide that number by 10 and find out what each individual angle is. So we will start with finding the sum of the interior angles using our formula that we just came up with. I know n is 10 because there are 10 sides. So 10 minus 2 is 8, and 180 times 8 is 1,440. So the sum of the interior angles is 1,440. So now what will each angle be? Well, there's 10 congruent angles adding up to this number. So I'm just going to take this number, divide by 10, dividing by the number of sides, the number of angles, and that will tell me what each individual angle is. each angle would be 144 degrees. Now you can only do this for regular polygons. If all the angles aren't congruent, then I might know what they add up to, but I wouldn't know what each individual angle is. But because all the angles are congruent, because this is a regular polygon, I can know what each individual angle is as well. So let's look at example 3. Find the measure of each of the interior angles of a regular 24gon. So it's the exact same type of question. It just was not given to you right here, the little helps to remind you to find the sum first. But that's the same process every time. It's a 24gon, so there's 24 sides. We need to first find out what all the angles add up to. We need to find the sum of the interior angles. So I'm substituting 24 in for n. So 24 minus 2 is 22. And 180 times 22 is 3,960. So this is what the angles are all adding up to. That's the sum. And remember, if the polygon has 24 sides, it has 24 angles. And all those angles are congruent because this is a regular polygon. So I got 24 congruent angles adding up to this number. If I want to know what each individual angle is, I just take that total and divide by 24. We find out that each individual angle is 165 degrees. Alright, let's look at example 4. If the measure of an interior angle of a regular polygon is 108 degrees, find the number of sides of the polygon and then classify the polygon. Alright, so how can we do this? We just talked about the fact that if it's a regular polygon, all the angles are congruent. Alright, I need an equation that I can use to solve for n, because what I'm trying to find right now is the number of sides, right? Find the number of sides. So I'm trying to solve for n. So I need an equation I can use to solve for n. So what we just talked about, if each individual angle is 108 degrees, if I were to multiply that times the number of angles, that would tell me the total or the sum of all those angles. And we had a formula for the sum of the interior angles. It was 180 times n minus 2. So this is a formula to find the sum of the interior angles. And this is also, in this particular case, a good formula for finding the sum of the interior angles, because I'm taking the measure of each angle, multiplying it times the number of angles. Remember, again, technically n represents number of sides. Remember, the number of angles is the same as the number of sides. So both of these things should be leading me to the sum of the interior angles, so they should be equal to each other. They should be leading me to the same thing, so they should be equal to each other. So there's my equation. And if I solve that equation for n, I'll know the number of sides. So let's get to work on this. So the first thing I'm going to do is distribute over here. So the left side of the equation is not changing right now. We've got 180 times n, and then 180 times negative 2. Now there's more than one right way to solve an equation. I'm just going to follow the procedure I've been teaching my kids this whole time. So when the variable's on both sides, I just, to be consistent, I've always been getting rid of the smaller one. So 108 is smaller, it's a positive, so I need to subtract 108n, which will leave me with nothing on that side. If I do an operation on one side, I do the same operation to the other side. Then we want to start getting that variable by itself. So here's n. I want to get rid of this 360. It's being subtracted, so I'm going to do the opposite and add it. 0 plus 360 is 360. And when we subtracted or added 360 here, we were getting rid of that. Alright, still trying to get n by itself. It's currently being multiplied by 72. So I'm going to divide by 72. And 360 divided by 72 is 5. So I just found the number of sides. There are 5 sides. And then once we found the number of sides, then we're also supposed to classify the polygon based on its number of sides. And a 5-sided polygon is a pentagon. Alright, let's look at example 5. Find the value of x. Alright, well, I see, how many sides do we have? 1, 2, 3, 4, 5, 6. There are 6 sides. This is a hexagon. And we learned earlier a formula to figure out what the interior angles should add up to. If I can find out what all these angles should add up to, since I'm only missing one of them, I can add up the ones I do have, subtract that from the total, and find out what's left over here, what this has to be so that these add up to the proper number. So let's find out what these angles should add up to. I'm just going to substitute the 6 in here for n. So 6 minus 2 is 4, and 180 times 4 is 720. So I know that all these angles should add up to 720 degrees. So that means if I were to add all of these angles together, if I were to add all these angles together, it should equal 720. So I would combine like terms right here. I would add all of these up. And 130 plus 130 plus 120 plus 120 plus 130 all adds up to 630. And then I'm going to subtract that 630. And 720 minus 630 is 90. So I know that this angle right here would be 90 degrees. So that these angles would all add up to 720 like they need to in every convex hexagon. Alright, let's do the same thing on example 6. So how many sides do we have on example 6? 1, 2, 3, 4, 5, 6, 7, 8. You got 8 sides. So what should all these angles add up to? Let's find out. Let's substitute that 8 into our formula. So 8 minus 2 is 6. And 180 times 6 is 1,080. So these angles should all be adding up to 1,080 degrees. So let's set it all up. You got an x plus 20 plus x plus x plus x. And again, you don't have to set this long equation up like this. If you want to kind of combine like terms as you're setting up the equation, then that's perfectly fine. I just want everybody to see where it's coming from. So I'm adding all the angles up, setting it equal to 1,080. Okay, so how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 x's. And then we have 20 and 20 we can combine, which gives us 40. And then we want to solve. We want to get x by itself, so I'm going to subtract 40. And then x is being multiplied by 8, so we divide by 8. And 1,040 divided by 8 is 130. So x is 130. So each of these angles is 130 degrees, and then 130 plus 20, these two angles would each be 150 degrees. But again, the directions just said find the value of x, so we're done right there. Alright, so far everything we've done has been dealing with the interior angles of polygon. Now we're going to take a look at the exterior angles of polygons. So what is an exterior angle? Most people should recognize the word exterior as kind of being on the outside. So exterior angles are angles formed by a side and the extension of an adjacent side. So what happens is there should be one exterior angle at each vertex. Now you got to be careful in how you do this. There should only be one at each vertex. You can either kind of move yourself around clockwise or counterclockwise, it doesn't matter, but you pick a direction and extend all the sides in that same format. So if I'm moving counterclockwise, I would extend this side this way, continue this way, and continue this way. And that would give me these 3 exterior angles. Now what I want you to notice is that the exterior angle always forms a linear pair with the adjacent interior angle. And we learned previously that linear pairs are always supplementary. They're always supplementary. So these two angles will add up to 180 degrees. So if these need to add up to 180, I just do 180 minus 30, and I know this angle is 150 degrees. Here's another linear pair, the interior and exterior angle. They need to add up to 180. So 180 minus 60, 120 degrees. Linear pair, 180 minus 90 is 90. So I know what each one of these exterior angles is now. So what we're trying to work towards right now is figure out what the sum of the exterior angles should be. So let's do this with each one of these and see if we can figure out a pattern. So let's find the sum for these exterior angles. If I add these up, 150, 120, and 90, if I add all those together, I get 360 degrees. So these exterior angles add up to 360 degrees. Let's find out what happens on the next one. So again, either clockwise or counterclockwise, doesn't matter, but pick a direction and extend all of your sides. Just take these segments and extend them into rays where they're continuing to infinity in one direction. And it should create exterior angles. So let's check and see what each one of those angles are. Remember, linear pair adds up to 180. So 180 minus 80 is 100. 180 minus 100 is 80. This will be 100. And this one will be 80. So there's all of our exterior angles. Let's add them all up. We got 100, 80, 100, and 80. So we add all those up. And these exterior angles add up to 360 also. All right, let's try it one more time. So over here, again, pick a direction. I'm just going to stay consistent with my counterclockwise movement. So I'm just extending each one of these sides from a segment into a ray, all in the same either clockwise or counterclockwise direction. I'm doing counterclockwise right now. And it'll create those exterior angles. Again, they're linear pairs. They add up to 180. So if this is 120, 180 minus 120 is 60. And since all of these interior angles are the same, it's going to make all of these exterior angles the same. Because in each case, again, those interior and exterior angles that are adjacent have to add up to 180. Now in this case, I can add these all up, but it's easier since they're all congruent to just multiply. Each angle is 60 degrees, and there's 1, 2, 3, 4, 5, 6 angles. So I just do 60 times 6. And what I want you to realize is that on every single case, the exterior angles are adding up to 360 degrees. It does not matter how many sides there are. The sum of the exterior angles is always equal to 360 degrees. The more sides you get, the more exterior angles you get, but they will each get smaller, and the sum will still stay the same. The sum will always be 360 degrees. So, with that information, now that we know the sum of the exterior angles is always 360, let's try example 7. It says, find each exterior angle. So, I know these exterior angles all add up to 360. So, I'm just going to set up an equation, adding them all together, and setting it equal to 360 degrees. So I can combine like terms. So 7 plus 4 is 11. 11 plus 8 is 19. 19 plus 5 is 24. I have 24 R's. And then R is being multiplied by 24, so we divide by 24. And 360 divided by 24 is 15. So R is 15. Now that's not our final answer because it didn't say to find R, it said to find each exterior angle. So I would need to substitute that number in. So here I would be doing 7 times 15, which is 105. So this angle is 105 degrees. I'd have 4 times R, so 4 times 15, which is 60. So this angle is 60 degrees. We got 8 times R, so 8 times 15 is 120. So this is 120 degrees. And then we have 5 times R, so 5 times 15 is 75. So this angle is 75 degrees. So we found the measure of each exterior angle, and you could always check your work if you needed to, because remember these angles should add up to 360. You could add them up and just make sure that they add up to 360 like they're supposed to, and they do. Alright, let's look at example 8. Given a regular octagon, find the measure of each exterior angle. So remember, octagons have 8 sides. It's regular, which means all the sides and angles are congruent. And we want to find the measure of each exterior angle. So we did the same concept when we were dealing with interior angles. Now, interior angles were a little more difficult. We had a formula we had to use to find the sum of the interior angles. But with exterior angles, they always just add up to 360 degrees. So if I want to find out what each angle is, okay, the octagon has 8 sides. It's going to have 8 interior angles. It's going to have 8 exterior angles. So I know I have 8 congruent angles that add up to 360 degrees. I have 8 congruent angles that add up to 360. So if I want to know what each one is, all I have to do is take that 360 and divide by 8. And that'll tell me what each individual exterior angle is. So each angle would be 45 degrees. So I have 8 congruent 45 degree angles. That way they're adding up to 360 degrees like they're supposed to. And the last one, example 9. The measure of one exterior angle of a regular polygon is 18 degrees. Find the number of sides and classify the polygon. So, one exterior angle is 18 degrees. They're regular, so all the angles are congruent. We want to figure out how many sides it has. Alright, if I take the measure of each individual angle and multiply times the number of angles, that will tell me what they add up to, what the sum is. And we already know for exterior angles the sum is equal to 360 degrees. So if each angle is 18, I'll multiply by the number of angles, and that'll tell me what they all add up to, which is 360. So there's my equation, and then I can just solve for n to find out how many sides we have. So n is being multiplied by 18, so we divide by 18. And that tells me there are 20 sides. And then we're supposed to classify. Remember, I only provided you with names for classifying up to 12 sides, and anything beyond that, we just use the number, attach gon on the end, so we would call this a 20gon.